Alright, the following video is on solving trig equations exactly. And before I get started, if you are unfamiliar with the shortcut to find the special angles for sine and cosine, then I am going to recommend, before you watch this video, to go to YouTube and type in trig hand trick. And there's lots of different videos that will show you how to calculate the special angles for sine and cosine using this trick. So I'll be using this technique throughout this video. So again, if you are unfamiliar with that, please watch those other videos first before watching this one. Now, so I've borrowed for the next 6 problems that I'll be doing, I have borrowed these problems from HMath. This is for IB Math SL, and specifically I borrowed 6 problems from page 262. So here's one of our problems. We have 2 times cosine of x plus the square root of 3 equals 0. And I want to solve for x exactly. The first thing I'm going to do is I'm going to subtract the square root of 3 from both sides. That's going to give me 2 times cosine of x equals negative the square root of 3. Because this is 2 times cosine of x, I'm going to divide by 2. 2 divided by 2 is 1, leaving me with cosine of x equals negative the square root of 3 over 2. Now I'm going to imagine that this is the square root of 3 over 2. It's not negative, but I'm going to imagine that it's not. So I'm going to try to replicate this and find the necessary angle. So from my cosine direction, I'm going to put down this finger here. That's going to leave 3 fingers up, so I put 3 into the square root. So I have the square root of 3 over 2. In order to get cosine of an angle that equals the square root of 3 over 2, I'm getting 30 degrees. So what that means then is that from my initial side here, I am rotating 30 degrees in order to find some point on my circle where my x value, on a unit circle, where my x value is the square root of 3 over 2. So I've rotated 30 degrees. Now, since I'm trying to find all x values between 0 and 3 pi, this interval right here implies that I'm going to solve for radians and not degrees. Well, if a half circle is pi, then I'm going to divide up pi into 6 different slices. So 30 degrees is also pi 6. So I'm rotating pi 6. But because this is negative, I'm going to, where is cosine of x going to be negative? It's going to be negative in the second quadrant, and it's going to be negative in the third quadrant. So we're looking for a rotation here, which is, well, if this is my x value here, the amount I'm going to go over for my x is the square root of 3 over 2, but in this, because I'm trying to find my x value, of course that's going to be negative the square root of 3 over 2. So we're looking at a rotation then here of pi minus this pi over 6, or 1 pi 6, 2 pi 6, 3 pi 6, 4 pi 6, 5 pi 6. So I have that x equals 5 pi 6. But it is also true that I'm going to get, this is the same, this distance here of negative square root of 3 over 2 is also going to be equivalent for this triangle here. So that means that my rotation here is going to be, this was 5 pi 6, 6 pi 6, 7 pi 6. So we get 7 pi 6. So that looks like what our answers are going to be. We have 5 pi 6 and 7 pi 6. But if I look at my limitations here, the limitations say that it's all x values between 0 and 3 pi. So we're looking for potentially another rotation of, well, to get 3, a half circle is pi, so that's pi. This is 2 pi, so 3 pi is here, which means we pick up this terminal side one more time. So that's so a full circle in increments of pi 6, a full circle is 12 pi 6, because 12 pi 6 can be simplified to 2 pi. So we have 12 pi 6, 13 pi 6, 14 pi 6, 15 pi 6, 16 pi 6, 17 pi 6. So we have an additional answer for x of 17 pi 6. So there you go. Let's look at a more complicated one. Let's look at this problem here, the square root of 2 times sine of our angle x minus pi fourths plus 1 equals 0. I'm going to subtract 1 from both sides. That's going to give me the square root of 2 times sine of x minus pi fourths equals negative 1. I'm then going to divide by the square root of 2 to both sides, and that's going to give me then sine times x minus pi fourths equals negative 1 over the square root of 2. Now, a square root in the denominator is never considered simplified, so I'm going to multiply by 1 in the form of the square root of 2 over the square root of 2, which is going to give me negative the square root of 2 over 2. So I, in fact, then have sine of x minus pi fourths equals negative the square root of 2 over 2. Now I'm going to try to replicate this. I have sine of an angle equals this particular, in this case it's my height. So we're really looking for when is sine of our angle going to be negative. Sine of our angle is going to be negative in the third and fourth quadrants. So let's try to replicate what this angle is. To replicate from our sine direction, I want to replicate the square root of 2 over 2. That means I'm going to put this finger down. That means that's 45 degrees or pi fourths. So we're dividing up our pi into 4 different pieces. And so we can see that our angle of x minus pi fourths, this is our angle, that equals 1 pi fourths, 2 pi fourths, 3 pi fourths, 4 pi fourths, 5 pi fourths, 5 pi fourths. We also have 6 pi fourths, 7 pi fourths. We have a 7 pi fourths. And, well, if we rotate it around again, we can see that we're not capturing another terminal side. But I have this, I'm told that we have this, that my angle is x minus pi fourths. But in fact, this rotation here is in terms of x, not our angle of x minus pi fourths. So for this x right here, I'm going to be subtracting pi fourths. So that gives me x minus pi fourths. I'm going to do the same thing for the 0. 0 minus pi fourths is going to give me a negative pi fourths. I'm going to do the same thing here. In terms of, with a denominator of 4, that's going to give me 12 pi fourths. So I have 12 pi fourths minus pi fourths is going to give me 11 pi fourths. So I have 11 pi fourths. So we're going to see, so at this point, for our angle of x minus pi fourths, how many different terminal sides do I pick up? Well, because I'm starting at negative pi fourths, I can actually rotate clockwise instead of counterclockwise. So I'm picking up a pi fourths already. So I have, I'm picking up, I should say, a negative pi fourths angle. So I have a negative pi fourths. And then we have those other two that we've already found. We have 5 pi fourths and 7 pi fourths. And so we're going to keep, we're rotating almost, well, 11 pi fourths, so almost 3 pi. So this is going to give us our 5 pi fourths. This is our 7 pi fourths. And then we're not picking up another one. So at the last step, we're just going to solve for x. If our goal is to solve for x, then we need to add pi fourths to each of these solutions that we found so far. So we have, I should say, of our angles that we found. But x equals then, if I were going to add pi fourths, that's going to give me negative pi fourths plus pi fourths is going to give me 0. Add pi fourths here, 5 pi fourths plus pi fourths is going to give me 6 pi fourths, and 6 pi fourths is 3 pi halves. And then we're going to add pi fourths to the 7 pi fourths. That gives me 8 pi fourths, and 8 pi fourths, of course, is 2 pi. So these are my answers to this particular problem. Now let's continue. We have another problem here. We have 2 times sine of our angle of x plus pi thirds equals 1. We're going to divide by 2. 2 divided by 2 is 1, leaving me with sine of x plus pi thirds equals 1/2. Well, when is cosine going to be positive? Cosine is going to be positive in the first quadrant, and it's going to be positive in the second quadrant. So we're looking at this rotation here. Let's look at this one. Let's recreate the 1/2 using our hand method. So for our sine direction, we're going to have to put this finger down. So that is 30 degrees. That will give me 1/2. My sine of my angle equaling 1/2. It means my angle then has to be 30 degrees. But because it looks like we're going to find our x value in terms of radians, not degrees, then our 30 degrees becomes pi sixths. So we end up having our angle of x plus pi thirds equals pi sixths. That's this rotation here. We're dividing up our pi into 6 different slices. Same with the second half of our circle. It looks like here we're starting with some negatives as well. We can rotate negative in the negative or the clockwise direction as well. So if we rotate, if we are going, so these are our terminal sides right here. This is the terminal side, and this is the terminal side. So if we rotate counterclockwise, we get pi 6 and 7 pi 6. If we rotate in the clockwise direction, I'm sorry, this was supposed to be 5 pi 6, because there's well, really 5 slices here out of 6. If we rotate in the other direction, this gives us 6 pi 6, 7 pi 6. So we have negative 7 pi 6. We also get negative 7 pi 6, 8 pi 6, 9 pi 6, 10 pi 6, 11 pi 6. So negative 11 pi 6. So we're now going to, we want to solve for our interval in terms of our angle. So we have x plus pi thirds. We're going to add pi thirds to our 3 pi. So with a denominator of 3, we're looking at 9 pi thirds. 9 pi thirds plus pi thirds is going to give us 10 pi thirds. So we have 10 pi thirds. And here we have negative 9 pi thirds. And then we add pi thirds to it. That gives us negative 8 pi thirds. Negative 8 pi thirds. So let's see, we have negative, it looks like, so we're rotating around, if we rotate counterclockwise, this is pi, here's 2 pi. We're not quite doing 3 pi, which means we wouldn't pick up another angle in that direction anyway. What about going in the opposite direction? What about going counterclockwise? We're picking up this one and this one. So we still have, let's see. We're still picking up the pi 6 and the 5 pi 6. So here's pi, here's 2 pi, and here's almost 3 pi. So we're going to pick up this one again. So this angle, so we have our x plus pi thirds equals negative 7 pi 6, negative 11 pi 6, pi 6, 5 pi 6. And let's see, we're going to be picking up, so 2 pi, and then we're going to pick up another one here. So that gives us 13 pi 6, 13 pi 6. And we are going to, are we going to be able to pick up another one? That's the question. So there's 13 pi 6, 14, 15, 16, 17 pi 6. 17 pi 6. And I'm not convinced that that one is, that's almost there. No, this one's a little bit too far. It's a little bit beyond this, a reach of 10 pi thirds. So now to solve for x, I'm going to subtract pi thirds from everything. So that gives me x equals, I'm going to subtract. This is actually what? Going to be 2 pi thirds is the same thing as 2 pi sixths. So I'm going to be subtracting 2 pi sixths from all of these entities here. So that's going to give me negative 9 pi sixths, negative 13 pi sixths. I'm getting, if I subtract 2 pi sixths, that's going to give me negative pi sixths, 3 pi sixths, or pi halves, halves, and 11 pi sixths, and that's it. So there you go. I think I have enough time for one more. Oh yeah, let's do this one. So I really want to keep this video at least under 20 minutes. I think 20 minutes is a little bit long already. So let's try to solve for x again. First thing, we're going to subtract 2 from everything. That gives me 4 cosine of 3x equals negative 2. Divide by 4, I get cosine of 3x equals negative 2 over 4, or cosine of 3x equals negative 1/2. So to replicate for cosine of 3x, to replicate 1/2, that's going to give me, from the cosine direction, to replicate 1/2, I'm going to put down my 60-degree finger. That would give me 1 square root of 1, which is 1/2. So 60 degrees, or pi thirds. So I have 3x, which is my angle, equals pi thirds. And, well, we need to find out where our terminal angles are. So this is pi thirds. Pi thirds is if this was positive. If this was positive. If this was positive. But it's not positive. It's negative. So where is cosine of 3? Where is cosine of our angle going to be negative? It's going to be negative in this quadrant and this quadrant. So we're looking at this rotation and this rotation here. So that's going to give us 3x equals, and if this is pi thirds, then this rotation here is 2 pi thirds. So I have 2 pi thirds, and this rotation here is 4 pi thirds. So I have 4 pi thirds. So for my negative pi is less than or equal to x is less than or equal to pi, I'm going to change the parameters of my interval. So that's going to give me what I need to do. So this x becomes 3x, which means I need to multiply everything by 3. 3 times x gives us 3x. This gives us 3 pi. And this gives us negative 3 pi. So I have this 3x equals, we can go negative, so negative 3 pi, so we're picking up one terminal angle here, which would be negative pi thirds, negative pi thirds. We're picking up another terminal angle here, which is going to be, I'm sorry, that was 2 pi, sorry, 2 pi thirds. We're picking up another terminal angle over here, which is going to give us negative 4 pi thirds. So that would give us 2 pi, negative 2 pi. And then we're going to rotate another pi, so that would pick up one more terminal angle here, which is going to be, so this one rotation is going to be 6 pi thirds. 7 pi thirds, 8 pi thirds. We're looking at negative 8 pi thirds. Now going the other direction, going counterclockwise, we're going to be able to pick up this angle here. That's 2 pi thirds. We also have this 4 pi thirds. Those are two angles that we already calculated, 4 pi thirds. So that gives us, that would be 2 pi, but we can rotate as much as 3 pi. So a half of a rotation around, we pick up this other one here. So that would be, we have 6 pi thirds, 7 pi thirds, 8 pi thirds. So we have 8 pi thirds. Let me make sure I did that right. So this would be 6 pi thirds, 7, 8, 8 pi thirds. All right, so now we just solve for x. So we have x equals, let me just put these in order. So we have negative 8 pi ninths, negative 4 pi ninths, negative 2 pi ninths, and then positive 2 pi ninths, that's a 2. We also have positive 4 pi ninths, and our last one is positive 8 pi ninths. So there you go. These are all the solutions for this particular problem. I hope that was helpful.